So today we are going to be looking at GeoGebra, which is a mathematics manipulative website focused mostly on geometry and how it can apply to mathematics. So today we're going to be looking at an activity called trapezoid transformation, where we're going to be exploring how to find the area of a trapezoid. So some standards that can go with this, and I'm looking at 6th grade right now. We have the NC 6G1, which is solving real world and mathematical problems involving area, surface area, and volume, where we are creating geometric models to solve real world and mathematical problems, to find the area of triangles by composing into rectangles and decomposing into right triangles, or refining the area of special quadrilaterals and polygons by decomposing into triangles or rectangles. And if we look at the Common Core math standards, these are pretty much the same. We're finding the area of special quadrilaterals, composing it into rectangles, decomposing into triangles or other shapes. So with this manipulative, we have pretty simple instructions, and it just says use the slider to transform the trapezoid into something else. So we can make it whatever we want to be, and it's really nice because every single point on this shape is movable, so all the sides you can move, and it is nice because this little line segment right here that goes from AB to the point C prime it shows us that it doesn't matter how we move this trapezoid and form it into something else, a triangle is going to be formed on this left side right here, because in the basics of learning about what a trapezoid is, you learn that a trapezoid is either a square or a rectangle with two equal or unequal triangles on the end. So we're just playing around with this a little bit. You can see that trapezoids come in all different shapes and sizes. And then up here, there's a little rotate slider. And so we can take the shape that we have made and we can rotate it a certain amount of degrees. So I'm going to rotate it 180 degrees. And we have some questions down here that we can talk about while going through this activity. So what does the shape become? So if we rotated our initial trapezoid right here 180 degrees, if we're just looking at these outside lines, we can see that it turned into a parallelogram. Or even if we rotated it back to 0 and, messed around with it a little bit and rotated it again, I'll just make a unique shape. If we rotate it 180 degrees, we are going to see that it is going to turn into a parallelogram, which is essential because finding the area of a parallelogram is something that we can derive the area of a trapezoid from, because it's very similar in the way of how you form your area. So I'm going to stretch this out right here. And you can see this line is back and we have two triangular shapes at the end of our parallelogram. And by manipulating this line right here, what this line is, if we rotate it back to 0 degrees, as you can see, it's the one of the edges of our initial trapezoid. And when we rotate this, it becomes a movable point where we can alter our lines of our parallelogram. As you can see right here, I've made another parallelogram, but it's made out of 2 right triangles. So just by messing around, moving some points, experimenting with different things on this activity, you can see that you can manipulate different shapes into finding a formula that works for you. Say I don't know the area of a parallelogram off the top of my head. Well, as you guys saw, I can move these points together, and this parallelogram is 2 distinct triangles, and I can find the area of a triangle. I know that one off the top of my head. So it would just make it easier to solve, for example. So if we rotate this back, we can see how our shapes can be split up into ways that make sense to us. So we're going to go back down here, and how are we going to calculate the area of the 2 trapezoid, and how can we calculate the area of just the 1 trapezoid? So I kind of went over this earlier. So if we rotated the trapezoid 180 degrees, we can see it forms a parallelogram. Now, if you know the area of a parallelogram, which is base times height, you can calculate the area of both trapezoids by doing base times height. Now, how would you find the area of just your 1 trapezoid? Well, depending on how your trapezoid is shaped, you can break it up into different ways. So right here, we have a triangle. We know that the area of a triangle is base times height divided by 2. And we can form a line down here with another triangle that is also base times height divided by 2. And then we have the area of a rectangle, which is length times width. So we could add all of those together, and we can get the area of our trapezoid. So we could break it down into two or more shapes that are simpler and make sense to us. Or we could also rotate it 180 degrees into another shape that we can manipulate, and we can go from there. So that is pretty much it. This is a great tool for just experimenting with trapezoids at first glance, seeing how they can come in all different shapes and sizes, and also seeing how they can be split up per se in more than one shape in order to find the area.